Thanks for tuning in to Minds of Tomorrow. I'm your host, Luis Acevedo, and with me today I have a Solidity developer. He's also the CTO of Pixelcraft Studio. I have with me Nick Mudge. So, Nick, thank you for coming on the show today, man.
Yes, thanks for having me.
Yeah, so I think a really good place to start, because we're going to talk a lot about cryptocurrencies and just blockchain, that whole ecosystem. So I would like to know how you discovered cryptocurrency and, how that led you into becoming a developer.
Yeah, sure. So I don't really know where I found out about it, but I got interested in it probably in 2017, just from the news, really, and then started investigating, looking at websites and documentation on Bitcoin and then Ethereum. And I was already a software developer, and in 2018, I had the opportunity to do something else. I developed manufacturing software, and so I thought that the blockchain was new, and I like new stuff. So in 2018, I just started reading the Solidity documentation from the website and digging in.
Gotcha. That's about the same time that I discovered cryptocurrencies too. It was around that 2016, 2017 timeframe. Now, so you were already coding and developing software before you were introduced to Solidity. Now, how did you start doing that? Have you always been fascinated with computers at a young age, or what was the impetus for that?
Sorry, for what?
When you started developing software,
yeah.
How did you get into doing that?
Okay, so I just I was in school, and there was sort of this optional course on programming, and I had already thought computers were interesting, and I took the course on programming, and I did good on it, and I liked it, and so I just keep pursuing that.
Gotcha. Okay, fair enough. So good foundation there for the Solidity development. Now, when you were looking into cryptocurrencies and reading about Bitcoin and Ethereum, what was it about Ethereum that attracted you?
Well, it attracted me that it was a platform that I could build lots of different possible applications, and that's what I wanted to do, was look at building things. And whereas Bitcoin was not really a platform for building all kinds of applications, and so that's what really interested me in Ethereum.
Gotcha. And now, I guess just for the viewer's sake, could you maybe elaborate on the differences between Bitcoin and Ethereum, because they have totally different functions and purposes?
No, I couldn't really elaborate because I'm not very familiar with Bitcoin. I'm familiar with Ethereum, so I pretty much ignored Bitcoin because I have had no interest in developing on Bitcoin. So yeah.
Gotcha. Well, there's not much development going on Bitcoin anyway. There's not much you can do on it, like you were already saying. So basically, the ability to build on Ethereum is what attracted you, and that's how you got into the Solidity development. So could you maybe, so you've done a lot of EIPs. Now, could you explain what those are?
Yeah, sure. So when you're building things on Ethereum, one of the great things is it's a really open platform, so anyone can start building stuff on it. And if you built something on Ethereum, other people can interact and communicate with what you've built. And in some cases, you want to build things that other people can use. And so in the case of like tokens, if you want to build a token, you want other applications and software to be able to use it. Well, they're only going to be able to use it if the tokens is done a certain way, and everybody agrees that it's done a certain way. It has a certain way to communicate or interface with it, and that's where standards come in. So like the NFT standards and the token, like the cryptocurrency ERC-20 standards, that those allow people to write software that works with lots of these different tokens. So that's where these standards, that's really where these standards help. They make things being built that can then be interoperable with a lot of stuff.
Okay. And what were now, from my understanding, you actually have, I know, an EIP that's in draft stage currently, but you also have a couple that have actually been accepted by the community, correct?
No, I don't think so. I think all mine are in draft. And
Okay, okay.
I mean, I haven't really cared. Like there's one at the ownership, which is very, very common. That one, ERC 173. Like I haven't really cared about pushing them to final because they're already useful. People are already using them. I guess I could push them to final. Even the diamond standard, I could push to final. I've been thinking about doing that sometime soon. But like they're already, for me, a standard is useful when it's being used. So in like the ownership standard, Open Zeppelin has it. It's used all over the place. I could push it to final, but I don't know who cares on that one. So like the diamond standard, it's draft. The technical parts haven't changed in many months, and I don't think it will change. But just maybe some of the information, like guidance in it, might change, and like so there could be like informational things. But I think it's pretty much done. So I'll probably push that final just so that it reduces confusion. So people go, wait, is this draft? Is it going to change? Is it not going to change? So push it to final, and people won't have to worry about that. So I think the pushing to final is useful for that. Oh yeah, so I guess when I was talking about standard, I was thinking about contract standards, but the Ethereum standards, the EIPs, they have different like categories and sections for them. Like there's like core EIPs, and that's for the development of the Ethereum nodes, like basically the development of Ethereum. It doesn't have to do with developing contracts specifically. So I guess there's different ones, but I'm mostly familiar with the contract standards, and I've worked on a few of those. And yeah, so.
Gotcha. And so could you maybe, I know you said that all your ER, and that's my mistake. I could have swore that I saw some things that you had that were finalized, but I'm not sure if you're familiar with that whole process and what it takes to, get something accepted by the core community with an EIP. But if you do, could you maybe walk us through that process and why you don't see it necessary to, maybe finalize it since you can already implement these drafts?
Yeah, sure. So there is EIP 1, which really gives the process for how a standard is supposed to work, how it's supposed to get started, and how you do it, and how you get finalized, and so on. So, but in a nutshell, I haven't looked in that EIP for a while, but from my experience that I remember right now, when you're going to make a standard, particularly a contract standard, you initially write up I guess basically a draft of it, the basic idea of it, some basic contract interfaces for it, motivation, rationale, and also it's good to have an implementation that implements the standard. So you can do that, and then you need feedback. You need to reach out to people who have done similar standards or similar work, and have them look at your standard, have them look at your implementation, get feedback. That helps gauge how much interest there is in the standard, and help guide. You can learn from other people's experience, and I found that very valuable, getting people's feedback, and also seeking out developers to have them look at it. And it also helps with adoption, because then more people are familiar with it, then they can start looking at using it.
Right. So essentially, it's like a peer review process, is what you're explaining.
Yes. And so then you revise the standard, and you can make your implementation better, and so on. You just kind of finesse it and improve upon it until it's done, until you're not changing it anymore, and get some people using it, and get experience, find the problems that happen, you might find out certain aspects are more useful, and focus on those things in the standard, and changing the rationale. So it's just getting enough experience with it and working with it enough to have something that's the most useful for people, that's most clear and understandable. And then I would say, push it to final. I think it is good to push for final, and I should work on that too. I guess as a standards, I wasn't, like paid to. I've done a lot of work on standards, and I wasn't paid to do it, and so it's sort of like on and off work sometimes, and like I was more focused on like, like what's going to like be, making it better, and but and so and I don't think it's very hard to push it to final either. There's a process for that. You change the status, you post some, you make an announcement, you post certain places that it's final now. There's EIP editors that will look at it, make sure it's all right, and make suggestions and stuff. So
Gotcha. So it's that whole process is essentially peer review and fine tuning whatever it is that you're trying to improve upon on the Ethereum network and make it as best as possible. And the reason that you're doing that, like you said, you're not getting paid to do this. This is something that you just enjoy doing, I assume. And you're also trying to bring more adoption to the Ethereum network, which is very crucial. I mean, a lot of people in the space talk about mass adoption. When are the masses coming into crypto and, Ethereum or the whole entire ecosystem? You have businesses wanting to use blockchain applications, but we're still in a very, very early stage, despite the fact that there's ridiculous prices out there for Ethereum and Bitcoin and things like that, which is what most people look for. So that's really cool that you're working on trying to make it more usable, user friendly, because that's the most important thing. And so I do want to talk about the Diamond Standard. That's actually what piqued my interest in speaking with you, because I was reading on it. I've been reading on it for the past few days, and I'm like, this is a really interesting concept, and I like where you're going with it. Now, before we get there, I think it's important to define what a smart contract is. So could you do that?
Sure. So I'd say a smart contract is a piece of software that's stored on a blockchain, and it's executable. And so you can execute this stuff on a blockchain, and it runs. And in a nutshell, that's what it is.
Mm-hmm.
The blockchain being this network of computers that share the same data, and run the same transactions and so on. And so you have the program that's stored on the blockchain. It gets executed by all the nodes, and and it updates the state across the nodes. So that's what a smart contract is.
Gotcha. So it's just kind of like a digital contract, if you will. I mean, is it even really, would you consider it smart? I know there's like a little debate going, like, would you even, like, I think I read something from Vitalik that smart contract may not be the best name for it.
Yeah. So I guess on the like, why is it called a contract is that I guess in like traditional world, a contract is something that doesn't change very often. Like you have a contract, it's a fixed agreement, and things work according to that contract. And then on the blockchain, there's some similarity in that you have this piece of software stored on the blockchain. Well, that piece of software you can't change it. It's immutable, like a contract. And so the rules, the way it works, which is kind of like the rules, are like a contract, saying if you execute this software, it's going to work this way, and that's it. And so in a way, to me, that's the contract part. Now they talk about these upgradable contracts. Well, I mean, that's really, once you store a piece of code on a blockchain, you don't actually ever change the code of it. You can just you can have a contract on there that's pointing to another contract, and it's using the code from another contract. And when you upgrade it, you're just changing where it's looking for its code. Instead of using contract A for its functionality, it's now looking at contract B. Okay. So and also in a contract, there's data in it. You can change the data, and changing the data can also change the way the program works. But of course the code there is fixed. So as far as smart contract, just in my own mind, I think that when you have a traditional contract, it's all written on a piece of paper, and that's it. Whereas on the blockchain, it's a program, and program can have variables, and it can have branching conditions, do things based on different conditions and so on. That seems it seems smarter to me than like a traditional paper contract because
Fair enough. Right. Right. I
and
would,
it's
I would
also
think, go
it's
ahead.
also smart in my mind because a smart contract on the blockchain, it executes, it's automatic. Once it starts, there's an automatic nature to it, whereas a a real physical contract has to be executed by people. You have to, you know, the contract says that Joe has to go, give money to someone. Well, he actually has to physically go and give money to, he has to do things. It's not automatic. Whereas smart contract is you call the function and it can do a whole bunch of stuff.
Right.
There's no human in it, so there's removing the human from it.
Right. And there's a lot of potential implications with that, as far as like in certain industries that it may replace some, jobs for lawyers and things like that. I've heard that before. But before we go down like the future implications of what the smart contract could do, let's talk about the diamond standard now that we know a little bit about what smart contracts are. So the diamond standard, if I understand correctly, you're making the amount of data that it can hold in the smart contract larger, correct? And there's probably some other things too that I'm missing right now. But the diamond standard, could you maybe go into that?
Yeah, sure. So on Ethereum, there is a smart contract that says piece of software. The amount of code that a contract can be is fixed. It's at about 24 kilobytes. You can't deploy a contract onto Ethereum if it's too large. And so that becomes a problem in some cases where you basically want to deploy a smart contract that's bigger. For example, an NFT token with some custom functionality. You want all your functionality to come from that one contract, and then you can't because it gets too big. So there's that aspect. So the diamond standard solves that by deploying a very small contract, and that then can utilize the code from a set of other contracts, and from the outside world or to outside contracts to outside user interfaces, the diamond appears to be one single contract with one single address, but a whole bunch of functions, whole bunch of functionality. So there's that aspect. It overcomes that limit, but it also sort of functions as a like a programming framework to some degree, because in traditional software, if you're going to build a website, you're going to build something that has some, it's kind of more complicated or it's bigger. You use a framework to help you get to your end product much faster. And so I'd say the diamond standard, because it overcomes the contract size limit, but it also starts organizing how you build a larger contract system. And so it sort of starts taking that place of a programming language framework for the blockchain. There's probably a bunch of parts missing for a good framework. And so I definitely would suggest developers to create contract frameworks utilizing the diamond standard, because I think that's a good fit. So it's for that. It's for creating larger contract systems that are organized, that are modular, and it also provides good upgrade functionality, so that when you're building a larger system, if you just need to replace like one piece of functionality, you can do that when you're using the diamond standard. Whereas before this, when you had a contract system and you had to make a change, you'd sometimes have to redeploy everything. So the diamond helps with that. You can just deploy what you need, and if you want to add new functionality, you can just add the new functionality without having to touch your existing functionality. And so that's nice. So it's good for that kind of upgrades, and it also has it also takes care of, like, when you do an upgrade, it's good to record, well, what changed, like what functions were added. And so it has an event that a standard event for that, and it also has some 4 standard functions that inspect the diamond, so that if you have a diamond and it's, as I said, it utilizes these other contracts for its functionality, you can query a diamond to say, well, what are the other contracts it uses and what functions does it use? So it provides, so the standard, provides a way to get transparency into the diamond that's standardized, so that software can work and look at diamonds.
Okay. And so if I understand correct, it's like a scalable solution for the contract, so that way you can actually have larger contracts without taking up so much space on the Ethereum network. Now, excuse me, I'm not as technical as you are, but is that essentially, kind of what you're doing there, like making the smart, like, so you're lumping more data into a smart contract as opposed to using multiple contracts, and this is more efficient on the network?
Well, it can be because when you create a diamond, as I said, it uses these other contracts. They're called faucets,
Mm-hmm.
and you can deploy a faucet piece of functionality once, and then you can deploy these diamonds that utilize the faucet. The faucet needs to be deployed once, but can be used by multiple diamonds. So basically, a diamond provides a way to reuse already deployed contracts on Ethereum. So that goes very much with it. Yeah.
Gotcha. And so why did you call it the diamond standard?
Well, for a few reasons. One, it had a name before that, but it conflicted with some Open Zeppelin functionality. They named something similar to the name I had, so I needed to come up with a new name or handle that some way. And then the other thing is I already had experience implementing diamonds, and from implementing diamonds, I sort of noticed there's a certain mindset, certain way you think about diamonds in your contract system when you're using the diamonds. And your mind, I'll just kind of try to tell you best I can, but basically a diamond divides functionality into different sets of functionality. So like maybe you have token transfer set of functionality, maybe you have ownership management functionality, like controlling the contract, who can do what in the contract. So and then maybe you have I don't know, a marketplace for selling tokens. Like, and you have all this functionality in your diamond, and so you separate things out into similar functionality, and each set of similar functionality is called a faucet. Now, in a real physical diamond, you have different sides of a diamond, as you can see behind myself. There's the diamond, so you have different sides. So in your mind, when you're developing a diamond, your mind is divided into these different things, different angles, different sides of your application. And so there's that connection with the physical diamond. The other thing that's a couple of things that are kind of similar are you have your diamond, and then you have these faucets. Now, the faucets, they all modify and add and manipulate data in the diamond. The diamond holds all the data, and the faucets do not hold any data. They're just the code that mutates the data in the diamond. So the diamond acts as a central container for your data, and the faucets manipulate it. And so your faucets are on the edges. Like in a real diamond, your faucets are on the edges, and all the faucets of a real diamond have a common center. And that's true with a diamond on Ethereum, is that your diamond holds all your data. It's the common center for all your faucets that it has. And then also your diamond contract, it has an address, an Ethereum address, in which you interact with the diamond. So that's also part of its centers. So with the diamond, its center is its address and its data, and then you have the faucets on the edges, which are all the different sets of functionality. So I call it the diamond because because that just is part of the mental model that you think with when you're developing with diamonds. It matches a physical diamond.
Gotcha. And I think I heard one of your other interviews too, that you were saying, I actually learned something from you as far as diamonds go. They're supposed to be the hardest thing in the world, but you can actually carve them down to size to how you want the diamond to look, essentially. And so that's also what you're talking about as far as like, adding these faucets in there too, right? So that way you're modifying the contracts. Is that correct? Am I understanding this correctly?
Yeah, that's correct. So when a real diamond is going to be available for retail sale, it actually gets physically cut to make it all beautiful and everything, and to make it the way they want. So they actually physically cut it, and when they cut the diamond, that creates more sides of the diamond. It creates faucets. And so in the terminology with the diamonds with Ethereum, kind of uses similar terminology. When you're going to add a faucet to the diamond, you cut it. You cut the diamond. This cut is like upgrading your diamond. So
Mhm.
so that's right. Yeah.
Okay. And now with this EIP, it's EIP 2535, correct? That's what it's
Yes.
called.
Yes.
Now, with this, how do you see this being utilized with, you know, companies and things like that, as far as people trying to use smart contracts, you know, for multiple use cases?
Yeah, sure. So first I'll say that, the diamond standard really is kind of a general base framework. So it's like really you could potentially build all kinds of things with it, and I'm really excited to see what people do with it. But there are some common use cases today that people are using diamonds for that make a lot of sense. So one of them is that when you're going to be building a smart contract system, an application that that once you deploy it and it's live in production, that it's going to you're going to extend it, meaning like you're going to add new functionality later in 3 months. You're going to keep doing development, and so you have a production system that you need to add to. And so a diamond is good for that, because it's because once you have a diamond, it can keep growing, and there's no limit to it. So and it's not hard to add more functionality to it. So there's that aspect. So like Avagachi, which uses a diamond for its contracts, it's really utilized that, whereas they're continuously developing more functionality and have a lot of plans in the future for a lot more stuff. And the diamond helps them to be able to add more functionality in the future, to their existing production system. So if you want a system that can grow, a smart contract system that can grow in a systematic, organized way, then the diamond is good for that. So there's that use case. Another use case that people are interested in is when you have a contract protocol, like a DeFi protocol, or something like that, and it has a DAO, and you want the DAO to be able to.
Could you maybe explain what a DAO is too?
Yeah, sure. Decentralized autonomous organization. It's a way, it's where you have members, a group of people who are able to control a protocol, and they have tokens, or they have some way to vote on chain to influence the protocol. So you might have a DAO where they have this idea where you want to be able to change things in the protocol or add new functionality to the protocol, but it should only be approved by the DAO, by the group, by voting. And so there's this idea that you could do that in various ways. Perhaps one way you could do it is that a new faucet is created by members of the DAO, and then they can vote on it. And then if it's voted, then it can be deployed, added to the protocol to change the protocol. So that a protocol can grow. Just another way for a protocol to grow in the future, using the DAO as controlling it. So there's that. Other use cases is I think that I tend to stress this a lot because people don't otherwise stress it. But I found that for larger contract systems, having a way to organize it is important, so you don't have spaghetti code, you don't have a hard to understand system. Whereas the diamond enforces a way to divide functionality, to organize it, and I think that's really useful for larger systems. And it separates functionality. So if you have one developer working on one set of functionality, he doesn't have to think about another set of functionality. He just because there's a certain amount of separation between functionality that's possible to do with diamonds. And then if you have a developer, working on a protocol uses a diamond, and then he goes to some other company that also uses a diamond, he'll be able to come up to speed faster because he's already familiar with diamonds. So I think it's useful for people to be able to work on lots of different projects. If they all use diamonds, it's just going to be a similar understanding of development, instead of like going to a new system that's completely different and have to learn everything from scratch. So
right.
Yeah.
And that's because it can store a larger quantity of data, right?
Sorry. No, it's what do you mean? Sorry, I'm sorry.
No, it's fine.
Yeah.
And it could be me, man. Could be me, not
So
fully
this is like
understanding.
I'm talking about like a learning curve. Like when a developer needs to start like on a project, he has to like learn like what's the development process, how is the code organized.
Yeah,
But the
yeah.
code,
And so I was actually referring to the diamond standard itself, like
yeah.
what you're talking about. The reason why, that learning curve may be reduced is because there's different functionalities in it. So you may not need, because like with the older versions of smart contracts, from my understanding, I'm not as technical as you are. You may need to do something completely new if there's too much data in this contract. Is that correct?
Oh yeah, yeah. I
And
mean,
that's what I was referring to with the diamond standard, that because you can hold larger amounts of data, you would reduce that problem. So maybe I should have worded it better.
well, yeah. There's definitely some truth there where you have an existing system and maybe it's an upgradable contract, and it's gotten big, and now you want to add some new functionality, but you can't add new functionality because you have to deploy the whole contract, and you're going to deploy a new contract that replaces the old one, and it's just too big now. And so there's that problem. But also, even if it's not a problem, if you're going to deploy a new contract, to do an upgrade, you don't have that separation of concerns, and so you're going to have to, so that it could potentially be more difficult there. Yeah. So, and then I think there's this is not so much a use case with diamonds now, but I think that it could be. And that's that, as I said, it allows when you deploy a faucet to Ethereum, it can be reusable, so that you could have a diamond that gets deployed. It uses faucet A, faucet B, and faucet C, and then you have another diamond that's deployed, uses faucet D and A. So I think it's possible to create interesting systems, or like libraries, reusable faucets, that might be useful for some applications.
For sure. Now, how do you see smart contracts interacting with the real world? Because right now, as far as I know, it's mainly just everything in the digital. Maybe there's some companies trying to do something with it in the physical, using a smart contract. Whether I've heard some wild ideas as far as homes being put on smart contracts, things like that. That doesn't really seem doable to me, at least at this time. But what are some physical applications for the smart contracts into real world?
Yeah, right. Good question. So, I do see that I think there'll be projects and companies that their product is connecting, they specifically connect blockchain to other things, to real world things. What the blockchain would be useful for real physical things. I'm not so sure, but I see potentially that things like ownership of things, which are usually tied to like paper or like government systems, where there can be a connect, where blockchain can be integrated with those things, so that your marriage license is on the blockchain, and your driver's license, and your ownership papers of things, of your house, of the deeds, things like this could be stored on the blockchain and connected perhaps in some way to government databases and paper. But for like controlling robots and things like that, or like I think it's potential. I don't know why it might be useful. It might be useful for like a big company that is doing manufacturing, and they have their own internal the technology, the blockchain in their company, so that as a way of having a company-wide way of tracking things, potentially using private blockchains for that might be useful. Yeah, I did see there's a paper about some researchers that want to like record data from mobile networks using blockchain for some reason, and I could send you a link to that. And they're actually using
Yeah, it'd be interesting.
they're actually using the diamond standard for their contracts for that.
Oh wow, that's pretty cool. So yeah, I was thinking about what myself. I was also
Yeah.
thinking about what could be used for the smart contracts in the real world, and um, it, you know indulge me with this real quick, and I want to hear your thoughts on this. The personal data. I was wondering, since that's already stored online, like your data is already, in some database, could that not be a way to maybe secure personal data a little bit better, to say, let's make a smart contract for this, and store your data in here. And then, you can decide who can interact with that contract getting your data. Maybe that doesn't make any sense, but.
No, I like that idea. I like the idea of using contracts to store personal data. I guess it depends a bit. Like, it wouldn't be like, if you're going to use something like Ethereum, or like a fork of Ethereum or something, it would have to be data that you'd want to be public, because like Ethereum is all public data. But so I think that could be cool. I think there could be uses of that kind of thing. I've long had the idea of, that a person could have their own smart contract, and then they could add functionality. They could, at their own permission, approval, they could add functionality to their contract to be able to do things like, to add functionality to their contract, and their contract would act as their wallet to hold their tokens and everything. So that kind of thing. I think there could also be blockchains that we have smart contracts where some of the data is actually encrypted, so that you could store your private information in it, and then give access to that private information potentially to other services.
Mm-hmm.
Kind of like, yeah.
Okay. Now, when you were talking about the wallets, I'm sure you're familiar with smart contract wallets. So what's the difference between what you were explaining and a smart contract wallet then?
I guess not much different, other than maybe that the wallet could potentially do other things rather than just with your tokens, but like you could use it to play games, or like to add all kinds of functionality to it that's that the user could remove or add. They could, like an app store, like on your phone, there's all these apps you can install on your phone. And the same thing with your contract. You could have all this different apps for your contract you could add or install onto your personal contract. So something like that. I think that maybe wallets are kind of probably maybe going that direction already, that kind of thing. I think a diamond is perfect for that, where everyone has their own diamond, and they can add at their own permission, they can add all of these faucets to their diamond. And each faucet is basically an application that they can add to it. Yeah.
Yeah. So.
Oh yeah. I think that the good thing, like for me, the most useful thing about these contract wallets is being multi-sig wallets.
And could you define multi-sig? I'm doing this for the audience.
Yeah. Yeah, absolutely. So you can have a contract, and it can hold funds like ERC20 tokens, Ether, whatever, and you maybe there's a lot of tokens in there, and you have your address, and you can control that contract. You can pull the money out of that contract, or you can send it somewhere else. But so the idea is that you can't do that yourself. It's just like another person or another set of people, they all have to approve a transaction on that contract to move money. So it's nice for security. So like if I got my my private key hacked, or someone found it, if I'm using a multi-sig, they won't be able to take the money, because it takes multiple people's private keys to be able to transfer money out of that contract.
Okay. Nice. Now, I did have a question going back a little bit to when you were describing the diamond standard, how essentially there's no limit to how much data can be stored in there, correct?
Yeah, well, I'd say, yeah, that's correct. I'd say more specifically that with a diamond, it has an unlimited amount of code that it can utilize. Okay. So like a contract is code, and there's only a certain amount of code that a contract can have before it hits the max limit size. So a diamond says you can have unlimited code, unlimited functionality. That's not really the data of the contract, though you can consider code to be data, because you can have an Ethereum contract, and it can actually store. There's no limit to the amount of data a contract can store on Ethereum, meaning like, how many addresses it can store within the contract, how many, I don't know, whatever data you want to generate. So the diamond is just how much functionality you can add. Unlimited functionality to it, unlimited functions, unlimited amount of code can be added to a diamond.
And so where I was getting at with that is you were saying that it's also, it could be, I inferred this, that it could be more efficient. But if there has to be a reason why your standard smart contracts have a limited size. So how could it be more efficient than if it's, you're upgrading the amount of functionalities it can do, code, data. So wouldn't it be, maybe I'm wrong, but taking up larger gas fees to run the functions as opposed to your standard? So I guess my two questions are do gas fees apply to this? And why were the standard smart contracts at a limited amount?
That's a good question. I should look into it myself more myself, but I think it has to do that when you do when you do a function call on a contract, it's going to load a certain amount of data from the network, and for some reason they wanted to limit that to 24 kilobytes. I think it's just like a technical limitation of retrieving data in some way, where if you go beyond that amount, it can potentially cause technical problems. I don't know all the details, but so I should probably look into it myself on that. Because it's really, because when you execute a transaction on Ethereum, that transaction has to get executed on every Ethereum node on the network. So that's can be, there's a lot, that data gets pulled and on every computer and everything. So it's a lot of work.
Right. Now, let's see here. So
to answer your question, is like, why is it more efficient for a diamond to, just thinking, I mean, I'd have to look at myself, but I think to my answer to my question is that, and I'd have to look, my sort of guess on this is that when you call a function on a normal contract, is you have to load that. Perhaps you have to load that entire contract to execute that function. That's what I'm thinking. I'd have to verify that. So you have to load, if it's 24 kilobytes, you have to load that entire contract. Okay, so if that entire contract is a megabyte, now you have to load a megabyte. Maybe your function only does some little thing, but you have to load the whole entire contract to get at that code. So you're loading a megabyte of data. Whereas with the diamond, you call onto the diamond, and the diamond, is split among all these other contracts. And so it, looks at, okay, function A is this faucet over here, and this faucet A is a small contract. Maybe it's only 10 kilobytes or 5 kilobytes. So it only has to load 5 kilobytes instead of a megabyte. So that's in my mind. I'd have to research that. That's kind of my guess on that.
Well, thank you for expanding on that, because that actually gave me some clarity too about what you were describing as far as, pulling other, data from other contracts into this other one with different facets. So what I was thinking, and maybe I'm not even sure if you're familiar with it, I'm assuming you are, edge computing and fog computing. Are you aware of that?
I am, to some degree, where you have these devices on the, kind of out on the edge of where it's communicating, and we're dealing with really usually like physical things and stuff.
Correct. Yeah. And so where I was going with that is just part of it is it's sifting through the data to only send or extract or send stuff to the cloud that's pertinent to it. And so would it be a fair analogy to say that the diamond contracts are sort of doing something like that too?
Yeah, I think there's an analogy of that. Yeah. So like when a diamond executes a function, it only has to load a little bit of code, a little bit of code, because each faucet is small. So, whereas if if it was just a regular contract, but big, then every time you called a function on, it had to load the whole entire contract. It's just more resource heavy.
Okay. And now going back to what your thoughts were as far as, physical applications for the and by physical, I just mean real world. I know it probably doesn't sound right saying physical because it's not a physical, tangible thing, but applications in the real world outside of the crypto world. You were saying, like governments, housing deeds, things like that could use these smart contracts. So do you and maybe this isn't something that you think about, but I would like your opinion on it. And that is, do you foresee these smart contracts replacing jobs to some extent then?
I think so. I think it removes some of the human work involved because it's sort of it's automating things. So it removes perhaps some middlemen where, you know, before a person might have to call someone, or they might have to, you know, put something into a website, but then a real person has to go do a bunch of work to get something done. Whereas with a contract, you just connect it to a user interface, and the contract does the work or most of the work. So I think it removes human work, and it can remove middlemen from financial things. So.
And that's the whole purpose of crypto in the first place. It's why it was designed to get rid of middlemen and give more power to the individual. So that way you're not, you just don't need a middleman. So contracts would further enhance, smart contracts rather would further enhance that, is what you're saying.
Yeah. And I also think that, and what I'm seeing is that when there's something successful in crypto, there tends to be a lot of people and projects that try to do something similar. So in crypto, I just see that there's going to be a lot of competition, and that's going to make competition in that area, automated market maker, Uniswap type things, or these things are going to get better and better and better because there's so much competition coming in as well. And so again, that's just gonna, more ways to remove middlemen, more ways to remove human work, because you'll have, more efficient systems because of the competition. So I see that as, seems like that's happening to me.
Right. And I would agree. There's a lot of competition going on, and it's a good thing. So that way, you can have the best rise. And even the ones that, it's kind of like, I believe his name is Thomas Kuhn, or I think that's his name, the guy who came up with the whole paradigm shift and science revolutions, and how basically there's a huge swing eventually, when you hit this paradigm shift, and the people who weren't innovating, so to speak, were still contributing to it. So the people in the free market, so to speak, when it comes to crypto, there may be a lot of unsuccessful projects, but the successful projects could learn from the unsuccessful projects and build from there, and maybe take the good from what they were doing. And so the same thing could be applied to, different use cases for smart contracts, I would assume.
Yeah, absolutely. I agree with you.
Awesome.
Yeah. There's a lot of sharing of smart contracts. A lot of the source code for contracts is open source. So there's a lot of that. So, yeah.
Now, I want to switch gears a little bit, because you're also, from what I was seeing on your LinkedIn page, you're kind of an entrepreneur too. You've started, it seems, either you're the I believe you were running the Perfect Abstractions. Is that correct?
Yeah, that's right.
And so could you tell us a little bit about that? And then also Pixel Craft Studio.
Yeah, sure. So so as I said before, I was I developed software manufacturing, and I was pretty much a freelancer for a while, where companies would hire me to write software for them for communicating with their equipment and things like that. So and then in Ethereum itself, I started freelancing with solidity development and doing some work for companies writing solidity. So mostly on that, I've hired developers in Perfect Abstractions. I have hired a team of programmers to work on stuff. So entrepreneur in that way. I made a project called Mokins, which was one of the first NFT where people could create their own ERC-721 tokens. I think I made that in like 2018.
And that's just with the ERC-271. Those are specifically for NFTs, correct?
Yeah, that's NFT token.
Yeah,
it's a standard for implementing an NFT token, one of the most popular standard for that. So, and then I'm just thinking. So then with Aavegotchi, the founders of Aavegotchi, Dan and Jesse, they liked the diamond. They saw that it was going to be a good fit for what they wanted to do. And so initially came out as an advisor, but then I liked what they were doing. So I came in and I worked on their diamond and their smart contracts and developed a lot of that. And then then Aavegotchi, and then so I've sort of stepped out of the development of Aavegotchi, but I'm still an advisor for the project, and they've hired other developers for that. And but now I'm more working on some things for the Diamond standard. Like there's some implementations for the Diamond, and I upgraded them to the latest versions of Solidity and some other work there. So I'm sort of that's kind of where I am right now. Yeah.
Gotcha. And so what is Aavegotchi?
Aavegotchi is it's a blockchain game. It combines NFTs with DeFi with ERC20 token, interest-bearing ERC20 tokens. So for example, if you have an Aavegotchi, it's an NFT, but it also holds interest-bearing tokens, which are tokens that increase in value over time automatically. So if you have an Aavegotchi, it's going to increase in value automatically because of what it's holding. But it has a lot of game functionality to it, so you have to go check it out. It can have like wearables, which are also tokens stored on the blockchain. So you can have an Aavegotchi, put a hat on it, pants, all kinds of stuff, and then there's a lot of other game functionality coming.
So maybe I'm not understanding completely here, but the Aavegotchi, is that acting like an avatar that you sort of put wearables on? Is that what you're saying?
Yeah, it could. Yeah, it's like an avatar. It could be. You could use it as an avatar. Or you can, just use it as an NFT that you're collecting.
Okay.
Yeah.
And
but
so
it also has functionality. For example, it has traits like, like its brain size, and it's like aggressiveness, and it has like these traits. It has a pet functionality, like it has like how happy it is, like and if you pet it, its happiness score increases. So, and then then there's some mini games. So there's a lot of, it's kind of, like Minecraft, where you have some basic building blocks, and Aavegotchi's kind of like Aavegotchi's its basic building block, but then there's more functionality being built for it, and then more things people can do.
Gotcha. So does it have its own unique NFTs then, or could people take their NFTs from anywhere, whether it be like a Ramble or OpenSea, and then apply them to the Aavegotchi?
Yeah, so I'd say both on that. So Aavegotchi, the token itself on chain can hold other tokens. So you can have an Aavegotchi, you can hold a hat token and all these other ones. So it's also possible to take a token that's disrelated from Aavegotchi and transfer it into an Aavegotchi, and Aavegotchi holds it. Now you won't be able to see that on a user interface unless someone programs a user interface to show that it's holding some other token. But on chain, an Aavegotchi can hold other digital assets, including other ERC20 tokens. So
okay,
you can transfer a bunch of different ERC20 tokens to your Aavegotchi.
But the only ones that would be interest bearing are those specific to the Aavegotchi network. Is that correct?
Well, you can transfer any interest bearing token to an Aavegotchi, but the user interface that Aavegotchi has it'll show the Aave is a DeFi protocol that has interest bearing tokens. And so Aavegotchi will show the Aave tokens with your Aavegotchi because the user interface is programmed to do that.
Gotcha. And so how does that work then? That sounds sort of like staking, but for NFTs.
Yeah, sure. It's kind of like that. I mean, you can hold interest-bearing tokens in your own at your own public address, and they're increasing value. Where you can also send them to your Aavegotchi, and hold it there. And I know that there's game mechanics planned for that. So like in the future, you could have one Aavegotchi playing a game against another Aavegotchi, and the one that loses some of its tokens to the other one, as an example.
So like Ready Player One type deal in a way. I'm not sure if you're familiar with Ready Player One, but if in the movie you die, you lose all your tokens, but in this you can lose some of your tokens too in a battle. So sort of gambling in a way.
Yeah, sure.
And so what was the inspiration for that? Because it seems, to me it's unique, but also, when I think of games, they don't last a long time. They eventually get old. Now, obviously you have your unique games like Minecraft that have been out for years and people love it. But, games seem to be easily replaceable. So what would be, the what makes Aavegotchi stand out, and what was the inspiration for it?
Right. So I think, that kind of question is best for Dan and Jesse, who are the founders of Aavegotchi, and really the brains and minds about how it all goes together and where it's going. But I think that they were interested in combining NFTs with ERC20 tokens and with DeFi. And Aavegotchi has really combined itself with a lot of high profile technologies. It uses Chainlink, which is has to do with oracles and random function data. It's partnered with Polygon. So I think that, and with other projects with Aava. So they and I think that to make themselves relevant, they have a Gotchi universe plan where there's gonna be land that you can have and put your Aavegotchis, and you can stake your Aavegotchis in the land and earn some other kinds of tokens. So I think that in Aavegotchi's case, it's because it's connected to Ethereum, which is connected with tons of functionality. Aavegotchi has tons of innovation to draw from and integrate with, and I think that could really help it continue to stay relevant, because Aavegotchi can continue to leverage new things that get developed on Ethereum and continue to grow and continue to develop and go in whichever direction makes sense, at whatever time.
Gotcha. That's pretty cool. I didn't know I didn't know much about Aavegotchi, to be honest, but so they're trying to create this virtual world essentially, where then you can stake your, tokens or whatever, your Aavegotchi. And so it's maybe edging on like a metaverse type deal.
Yeah, that's right. Yeah. They have a new white paper out about that can be checked out.
Oh, okay. Cool. I'll have to do that. Now, are you a gamer yourself?
Yeah, I mean, I've played games. I don't know if I consider it. I'm not a hardcore gamer. I try not to get too much into it, because then I'll get too much into it. But I like games. Yeah.
Right on. What are your go-to games?
These days, I like to. I think the last game I played recently was a little game called Bad North, which is not a blockchain game. It's just kind of like a little Viking kind of game. I've played Aavegotchi. Let's see. I played 0x Universe, which is like it's kind of a space blockchain game.
Okay.
Yeah, so those are the ones that come to my mind right now. In the past I played like Diablo 2 and StarCraft and Warcraft and stuff.
Gotcha. So more of a PC gamer then?
Yeah.
Right on. And so you were saying blockchain game. One of the last games you listed off before you went into like Diablo 2 and World of Warcraft. How does that work? And why would you want a blockchain on a video game?
Well, one of the great things about a blockchain game is that the assets in the game can be NFTs. They can be assets that you own on the blockchain, and so I think that's really, really cool, because you play this game and you earn these assets, and or you get them, and maybe there's things you can do in the game to make your assets better. And then you can then send your game, your character, your gun, whatever, to another player by doing a blockchain transaction. Or you can maybe there's a bunch of blockchain marketplaces. You can sell it. You can buy it. Then there could be another game that uses assets from another game, because they're all on. So I just think that the being able to own your assets, the blockchain really allows you to own your asset in a way that traditional games don't. So I think that's really powerful. And then the interoperability potential of games and other services is really, really powerful.
That is really cool. I didn't even consider the bridging between other that's a really cool idea. And do you see, maybe this is a dumb question, but smart contracts even applying to video games in the future, as we expand on this blockchain expedition.
Like making a game like that that has to do with writing smart contracts, or like based on smart contracts, or
Well, no, just with maybe you would have to have that, but more so like using them in some way. Like I'm not sure if I'm asking the question properly, but whether it be like getting like, I don't know. I guess maybe I'm not asking the question the right way, but
that's okay.
Go ahead.
No, like with Aavegotchi, there's a pet function, and you want to keep your Aavegotchis happy, and you have to pet. When I say pet, that's an on-chain transaction that you need to do. It's like, and you can pet your Aavegotchi every 12 hours. So that's calling a smart contract to keep them happy. And you might think, well, God, isn't that going to be expensive? But Aavegotchi is actually deployed on Polygon, which is it's all compatible with Ethereum, but it's the turns of the cost for transactions is way lower, so it's not a problem. So that's an example, and so a lot of these games, they require on-chain transactions where you call contracts. So I do see that there could be games that are more like that teach you how to write smart contracts, and I think there's websites out there that you're learning smart contract development by playing a kind of game that teaches you along the way.
Gotcha.
I don't think that's really what you're asking about, but blockchain games, like there could be different kinds of blockchain games. Like you can have a blockchain game where it's really not blockchain, it's like your traditional game, but then you can export your assets from the game. You can export them to the blockchain so that they're now exported to the blockchain, so you own it on the blockchain. But then you can have a blockchain game where most of the actions you do are transactions that are or they're calls on functions on smart contracts. That's like Aavegotchi is really a blockchain game where like all the actions you do is going to change the state of smart contracts, and it's even the artwork, like the display of your Aavegotchi, that artwork is stored on the blockchain. So it's all on the blockchain there. So the different levels of games here, where you can have part of the game on the blockchain or most of the game on the blockchain.
Gotcha.
You have most of the functionality being done by smart contracts. Again, Aavegotchi, most of the functionality is smart contracts, where you have a game where only some of the functionality is on smart contracts. You can have just where just the assets are on the blockchain, but all the functionality is using other software.
And so do you see this becoming more popular as the blockchain becomes better and more it's used more widely throughout video games? Do you see that potential, especially like when you get into what we were just talking about, the metaverse and fully immersed video games, things like that? Do you see the blockchain playing a crucial role in that?
Absolutely. I'd call it a growing trend that's going to continue to grow, so definitely, like virtual reality is a trend. Everyone knows that, there's going to be more and more virtual reality things. I think blockchain with games is one of those trends that'll just continue to grow, and people will continue to innovate to do different kind of games with blockchain for sure.
Right on. Well, Nick, it's been very educational, man. I've learned a lot about smart contracts, about the Diamond standard, even blockchain, video game based blockchains. That's new to me, and I can definitely see the use for it now after you going into it a little bit more. Well, like when I first heard the idea, when you were talking about that just didn't really make too much sense to me, because I was thinking, it's an immutable ledger. Why would you want this distributed immutable ledger on a video game? Wouldn't it take up too much space? How would this really work if it's decentralized? And so it just seemed, and maybe it's because I don't have the mind that you do to initially see that possibility. But the bridging between servers, that's a pretty cool concept. So yeah, man, I really do appreciate you taking some time out of your day to come on the show. Good conversation, like I said, very educational. So yeah,
great. Thanks Lewis, for it was great talking with you about all this.
Yeah, man. Well, you have a good rest of your day, and yeah.
All right.